Good day to all. Today we are going to see about the chopper control of separately excited DC motor, forward and motor. See here, the mechanical energy is converted into electrical energy by the motor. Now it's working as a generator, partially increase the stored magnetic energy in that armature circuit inductance, and the remainder is dispatched in armature and the transistor. When the transistor is turned off, the armature current flows through the diode T and the source V and reduced from IA to IA1. Then the stored electromagnetic energy and the energy supplied by the machines are fed to the source. The interval of 0 to T on is called energy stored interval, and the interval T on to T is called duty interval. See, there's a forward motoring and braking. We have in that forward motoring, operations of the chopper is obtained by the transistor TR1 with the diode D1. The transistor TR2 and the diode D2 provide the control for regenerating braking operations. For the motoring operation, transistor TR1 is controlled, and for braking operation, the transistor TR2 is controlled. Shifting of the control from TR1 to TR2 shift the operation from the motoring to braking, vice versa. Now we'll move to dynamic control. See, dynamic control braking circuit and its waveform are shown here below. During the interval of 0 to T on, the IA is increased from IA1 to IA2. The part of energy is stored in inductance and rest is dispatched in RA and TR. We'll see the diagram here. If we get the power supply, then in this power will move over here. Here the energy storage in that inductor. When it is turned off, we will get the energy storage from this L part to we will get the current over here. Now we'll see the graph from T on 0 to T on time. The IA current will increase with the IA2. Then it will decrease some more time after T. Then that will increase. This is the dynamic braking. Then the slip recovery scheme. See, this slip recovery, from the word itself we will know that it's recovery something. What is that? We will see here. See the diagram. There is a 3 power supply over here, and there is a slip ring induction motor. Then it will be a bridge rectifier, a smooth reactor, and the inverter. Then it will connect again to the supply. Now we will have a 3-phase supply to the rotor. From this rotor, we will have electromagnetic waves in that. We'll have a AC supply to the stator. That from the stator, we will have a rotating magnetic field in that rotor. So that AC will come here with the stator, and that stator, the electromagnetic force EMF will induced in that rotor side. So this rotor will get into the bridge rectifier. What is the work of rectifier? It converts that AC to DC. Here is the conversion is taking place for conversion of AC to DC in that bridge rectifier. Then after that, the smooth reactor is connected with this bridge rectifier to have a smooth output of that DC. Then it will connected to the inverter bridge. What is the working of inverters? It will again convert that given DC power to AC. That will occur over here. The DC will convert the AC from this inverter bridge. After that, we will given to the particular supply for this given AC. The main concept over here, if there is a slip power from this rotor, we will recover this power here also. That is the main concept over here in that slip recovery scheme. First, it will have a AC supply over here, and we'll have a rotor rotation with the help of this stator. And it will go for a bridge rectifier. Then it will convert to the inverter. This inverter will go and will receive that AC again to that power supply. This is the slip power recovery scheme with this bridge rectifier and that inverter. The other model of this slip power recovery scheme we'll see over here. See, this is the basic model of slip power recovery scheme. Here also same thing will occur. We'll have a AC supply over here. Here also AC supply. This is the stator side and this is the rotor side. Instead of bridge rectifier, we will have a normal rectifier over here. And instead of that 6 inverter, we will have a single inverter over here. And here it will be the transformer. What is the process over here? We will see. We will get the AC supply to this stator side, as well as the rotor receive that rotor is rotating with the help of this stator. Then this rectifier here, it is used to convert from that given AC to DC. Then this will make as a pure DC output over here. Then this inverter, which is used to convert that particular DC to AC supply. Here the conversion is taking, here is DC to AC, and here the conversion is taking place from AC to DC. Alternating current to direct current, it takes place. Then here the pure DC voltage will come. After that, here the DC to AC voltage conversion taking place over here. Then this will connected with the transformer. Why we are connecting the transformer over here? Which is the step up transformer. See, after coming this AC alternating current, we will step up the power over here. So here we will step up the current, and this current will give into the circuit again. From that we will have to use this recovery power over here with this step up transformer. Here the step up transformer, it will give the output of this particular AC in higher range, because as we know already, what is the main purpose using step up transformer? Transformer is used to increase the given voltage to higher voltage. If it is step down, means we will have a less number of output compared to input, but here we will have a more output compared to input. So here we will have a huge number of output over here. So likewise we will use the uh, recovery rotor recovery current over here. These are the two types of the slip recovery scheme. Thank you.